Hello class, welcome to section 15.1. Moving on to organizing and visualizing data. So looking at things like frequency charts and really learning more about the statistical part of this particular book. First, some definitions. Population is very similar to the universal set group that is under consideration. So for example, if we're looking at a classroom, for example. The classroom would be considered the population, and then within that classroom you have different groups, and also called samples. Samples are subsets of population. So the population being, it could be just a general population, it could be a population in a smaller context. For example, if you're surveying people at a grocery store, your population is of course everyone you survey. Or it could be everyone who regularly attends that grocery store, or goes to the grocery store. Bias, factors that affect the objectiveness of a study. Poor sampling techniques, errors in reporting data, even bias is created by the participants in your study. Some of the more common ones, or more significant ones, are selection bias, which is where you choose a sampling technique that restricts the way participants are chosen. For example, if you're doing a survey at a grocery store, for example, if you only do and you ask them a certain question about maybe even a political question, but you only ask it to, for example, women in between 9 o'clock and 11 o'clock in the morning, that'd be selection bias. Especially if you're trying to say this particular study is all-encompassing, is a good representation of a larger population. So that's selection bias. Also, if you're trying to survey people's opinions on, let's say, gender equality, but you only survey one gender, obviously that's selection bias. Leading question bias is obviously asking a question in such a way that confuses or leads to a certain response. So overly wording a question, using a lot of double negatives, saying nots and nots, thens, is again overly wording it. One of the other good ways of an example of leading question bias, I should say, is, if those of you who are familiar with Stephen Colbert, he of course does a great satire show, and one of the things he does is he often uses leading question bias when he interviews people. One of the best examples I can think of is, this is during the Bush administration, he asked one of his guests, what is your choice? George Bush, great president, or George Bush, greatest president? And so this is, of course, leading question bias. His question is leading them to a particular response, obviously one that you would want. Now in this section we're going to focus on the way we organize data with frequency tables, bar graphs, and histograms. Frequency table, as you can see, is a table or chart where the number of occurrences of a particular value are organized in the columns so that the percent of each value is shown, sometimes called the relative frequency. So it's just a way of organizing all your data values. So even something as, if you survey people for one question and it's yes, no, and you just put into columns how many people checked yes, how many people checked no, that's a frequency table. Those of you who learn to count with the little hash marks, 1, 2, 3, 4, and then the slash for 5, it's an idea of a very basic frequency table. Some particular types one is a bar graph. So instead of just putting numbers, which we'll see in a minute, you organize them into bars that represent the data values based on their size. A histogram is a type of bar graph used when dealing with a continuous variable quantity. In other words, if you're dealing with a quantity or quantities that are changing over time, then a histogram is used. And it's essentially the same thing. The only difference is a histogram allows for that change. It specifically is a category where you can expect change over time, so it will adjust. Bar graph is more static. It's values are set, and this is the result. And finally, a stem and leaf display, sometimes called a stem and leaf plot. A side-by-side representation of data. This is another way to present it, usually grouped by tens. So as you can see here, and I'll show you a better example in a second, but we have a stem, 3 and 4 are my stems, and that's supposed to be one continuous line. Just it didn't show up. It didn't show up too well in PowerPoint. And then the leaves over here on the right. So for 3, it's my stem. My leaves are 3, 5, 6, 6, and 9, and similar for 4. So these represent the numbers 33, 35, 36, 36, 39. And you can see that the 3 in the stem represents the fact that we're dealing with the 30s. The leaves then represent the individual scores or numbers in this particular data set. So for 4, the 2, 2, 6, 6, 6, 8 represents 6 values in the 40s, being 42 twice, 46 3 times, and then 48. So let's take another look at this. And let me zoom in. So now we have scores on an exam are as such. Now one of the first things you should do when you are asked to organize a histogram or frequency table or anything like this is to put them in order, preferably from least to greatest. It'll make things easier for you. It'll also make it easier on your eyes, so it's easier to see what numbers are coming when. So this one, a frequency table, I organize it in groups of tens because it seemed to work well. So the scores, these are also called bins. No, oops. Let me try to write this here. So scores, let me get in here. They're also called, yeah, I'll get it. There we go, fine. Bins. Or sometimes even referred to as intervals. They have a variety of names. The idea is, from a frequency table, when you make it, you want to choose those yourselves. And there's not necessarily a set way of always choosing these. You want to do it such that you don't want to have hundreds of individual columns, individual frequencies. You want to have a good idea is you don't want to have like 1 or 2, but you don't want to have like 30. A good number that I tend to go by is anywhere from about 4 to maybe about 7 or 8. That's kind of my own personal ranges that I like to use. So in other words, I'll choose these scores, bins, intervals, these classes, whatever you want to call it, such that it organizes all my scores into about, I like to use around 4, maybe 5 frequency columns, or rows in this case. And I just chose what came naturally, 60 to 69, 70 to 79, and so on and so forth. Because if you choose more than about 7 or so, then the data has no meaning, especially when it comes to a bar graph. One of the things you really want to avoid, and this happens a lot, you don't want to have it such that for each individual score, you have one single bin, one single bar on a bar graph, for example. So for this one, you do not want a individual bar just for 89, just for 74, just for 65, and so on and so forth. And of course, the difference between my classes is generally 10, and again, this is up to you, whatever makes the most sense for you, unless, of course, you're instructed otherwise. So using the same data, if I create a histogram, and here again, it's the reason why you want a fair number of data sets. If I have 20 bars, all with one value in it, it makes the data worthless. This way, we can see, all right, most of the scores in this particular exam were in the B range. So it allows you to make inferences about the whatever it is you're talking about. Now another thing is, in Microsoft Word, of course, is where I made this table. You can make them in Excel, you can even do it by hand. On a test or quiz, of course, if it's proctored, then you do it by hand. If it's electronic, it will set it up for you. For those of you who are unfamiliar, because it's a handy tool. Now this is the new Word. It's 2010, so depending on what you have, you want to go to Insert, and then of course, Chart. And it will allow you to enter in your data values over here. So finally, a stem and leaf plot within the same one. You can see here, again, here's my frequency chart, frequency chart, and then I have my stem and leaf plot on this side. So again, since there are 3 scores in the 60s, I choose my stem to be 6, leaves being 1, 4, and 5. There are 4 scores in 7, 3, 0, 4, and 7. Now one thing you notice about my stem and leaf chart is that it's ordered from least to greatest. You don't have to do that. This is called an ordered stem and leaf plot. Obviously, if it's not, it's just called a standard stem and leaf plot or stem and leaf diagram. As far as I'm concerned, it doesn't matter to me what the order is, as long as, of course, the data is properly represented. Now, let's go back up to our frequency table. And I talked about relative frequency. Relative frequency stems from, again, the percentages of what we're looking at. So, in other words, let me make a new column here, and let's see how much Microsoft Word wants to cooperate with me. Not too well. Let's see. What I'm going to have to do is let me split. Actually, let me just insert to the. There we go. Okay, I had to do that while I pause it because Word is not cooperating with me right now. So now let's look at the frequency, and again looking at our percentages, or relative frequency or frequency percentages. So total, we have 7 plus 9, we have 16 values. So we say what percentage is each of these frequencies. So this one then is obviously going to be 3 out of 16, which will say gives us about 18.75%. This one then would of course be 4 out of 16, which is 25%. This one becomes 6 out of 16, which is then going to be 37.5. And then lastly, again, we have 3 out of 16, which again is 18.75. So again, this is our relative frequency. The first one makes up 18% of the overall data values. Next one's a quarter, and so on and so forth. So relative to the overall population. So again, to review, whenever you have a frequency chart, you want to determine the proper amount size of the bins, the scores, whatever you want to call it. Again, my recommendation is between about 4 and maybe 7 bins or classes. Makes for a good amount, but you don't want, for example, you don't want like 1 or just 2, and you don't want 1 bin for each individual score. The relative percentage you get, of course, by taking the frequency divided by the total number of scores. Histograms or bar graphs. are made by using that data and turn it into a bar of relative size. And stem and leaf plots, as you can see, are a similar way of organizing data, usually by tens. This concludes section 15.1. As always, if you have any questions, feel free to contact me.